Good day, dear learners. Welcome to another episode of Learn Math with Doc Gilmac. Are you ready, class, for the next lesson? So if you're ready, just sit back, relax, and listen carefully to the topic to be discussed for today. Alright, class, let's begin! The topic I will be discussing for today's tutorial is all about the graph of y is equal to tangent bx. How do we graph the tangent function? The first thing we have to do here is to identify the frequency. The frequency is simply denoted by b. Number 2, we must identify the period t, where t is just equal to 180 degrees over b, which is the frequency. Number 3, we must determine the increments 0 degrees, t over 2, and t. Number 4, we must find the coordinates of the key points. Take note, we are simply looking for the key points in one cycle. 0 degrees and 0, t over 2 and a, which is the asymptote, t and 0. Number 5, we can now sketch the graph of y is equal to tangent dx. Take note, in one cycle. Consider illustrative example number 1. Sketch the graph of y is equal to tangent 2x. The first thing we have to do here is to determine the frequency. The frequency is simply equal to 2. Since the given equation is y is equal to tangent 2x, then we compute for the period t. T is just equal to 180 degrees over b, which is just equal to 180 degrees over 2, which is simply equal to 90 degrees. Then we find the increments. That is simply t over 2, which is just equal to 90 degrees over 2, which is 45 degrees. Therefore, the increments in one cycle are 0 degrees, 45 degrees, and 90 degrees. Then we determine the coordinates of the key points. So we have 0 degrees and 0, 45 degrees and the asymptote, 90 degrees and 0. Let's now consider the graph of the given function y is equal to tangent 2x. Take note, all we have to plot here is simply the increments of the given function y is equal to tangent 2x. So let's just plot from negative 45 degrees to 225 degrees. By the way, the increments in one cycle are 0 degrees, 45 degrees, and 90 degrees. I have just extended the given increments into at least 2 cycles here. So from negative 45 to 225 degrees. So let's plot the increments, negative 45 degrees to 225 degrees. If we are to test the value of 45 degrees in the given function y is equal to tangent 2x, we simply have y is equal to tangent 90 degrees. And take note, tangent 90 degrees is undefined. So therefore, we have the following asymptote in 45 degrees. So that's the asymptote. Negative 45 degrees, 45 degrees, 135 degrees, since tangent of 2 times 135 is tangent 270 degrees, is also undefined. So therefore, that will be the asymptote. And 225 degrees, tangent of 450 degrees, is also undefined. So if we are to graph the tangent 2x, we have this, So as you can see, I extended the graph into 3 cycles. Consider illustrative example number 2. Sketch the graph of y is equal to tangent 6x in 1 cycle. This time, I will be showing you the graph of y is equal to tangent 6x in only 1 cycle. So the first thing we have to consider is the frequency. The frequency is just equal to 6 since the value of b is 6. And we compute for the period t 180 degrees over 6, which is just equal to 30 degrees. Then we find the increments, that is t over 2. So we have 30 degrees over 2, which is simply equal to 15 degrees. So we have the following increments in 1 cycle: 0 degrees, 15 degrees, and 30 degrees. Then we determine the key points of y is equal to tangent 6x in 1 cycle. So we have 0 degrees, 0, 15 degrees, and the asymptote, 30 degrees, and 0. So let's have the graph of y is equal to tangent 6x in the Cartesian plane. Let's have first the test value. So tangent of 0 is simply 0. Tangent of 15 degrees times 6, that is 90 degrees. So which is simply undefined. So that will be our asymptote. Then 30 degrees times 6 is 180 degrees. So that is simply equal to 0. So if we are to plot the given increments here, we only have 0 degrees, 15 degrees, and 30 degrees. Wherein the asymptote is in the 15 degrees increments. So as you can see, we have now the graph of y is equal to tangent 6x in 1 cycle. So this is just the graph of y is equal to tangent 6x in 1 cycle. Take note of that. Consider illustrative example number 3. Sketch the graph of y is equal to tangent 1/3 x in 3 cycles. So the first thing we have to do is to determine the frequency. So we have b is just equal to 1/3. Then compute for the period t, that is simply 180 degrees over 1/3, since t is just equal to 180 degrees over b. So which is simply equal to 540 degrees. Then we find the increments, that is t over 2. So we have 540 degrees over 2, which is just equal to 270 degrees. Therefore, the increments are 0 degrees, 270 degrees, 540 degrees. Then we determine the key points of y is equal to tangent 1/3 x in 1 cycle. So we have 0 degrees, 0, 270 degrees, and the asymptote, since 270 degrees divided by 3 is 90 degrees. Take note, tangent 90 degrees is undefined. So therefore, that will be the asymptote. Then we have tangent 540 degrees over 3 is simply equal to 0. So let's graph in a given Cartesian plane x and y. So let's just plot the increments from negative 270 degrees up to 1350 degrees, since we are to graph the given function in 3 cycles. Okay, so negative 270 degrees is the asymptote, positive 270 degrees is the asymptote, 810 degrees is the asymptote, and 1350 degrees is the asymptote. So let's now graph y is equal to tangent 1/3 x in 3 cycles. So there you have it, a graph of y is equal to tangent 1/3 x in 3 cycles.